Hi everyone. In this video, we are going to discuss how to solve exact differential equation. Okay. So what differential equation we have? First of all, we will check it is exact or not. And if it is exact, we will discuss how to solve it. Okay. So in previous video, we have already seen what is exact differential equation. Like let us recall the concept. When you have differential equation in this form, m dx plus n dy is equal to 0. Okay, the differential equation should be in this form. What is m? M is a function of x and y. It can be x square plus y square. It can be e raised to x sin x like that. And n is also a function of x and y. For example, x tan y. It can be anything. Getting m and n are functions of x and y like this. First bracket into dx, which is over m, and second bracket into dy, which is over n. So the differential equation should be in this form. We say this differential equation is exact if delta m by delta y is equal to delta n by delta x. What is meaning of it? It means the partial derivative of m with respect to y must be same as partial derivative of n with respect to x. If this condition is satisfied, we say it is exact differential equation. Now the question is how to solve it. See, no need to worry. There is a fixed formula to calculate or to find the solution of exact differential equation. So let me write the formula. The formula is integration m treating y constant dx plus integration terms in n free from x dy is equal to c. So this is a solution. Getting in solution, we have the sum of two integrations. Integration of m by considering y constant, and we integrate terms on n which are free from x. That means x should not be there. For example, you can see this is our n. This is our n, which is multiple of dy. This is our m, which is multiple of dx. How many terms are there in n? Two terms. This is first term. This is second term. In a first term, is there any x? Yes, there is a x. So you cannot take the first term. In second term, is there any x? No. That means you can take here the second term. You can integrate with respect to y. By finding the value of these two integrations, we take the sum and it is equal to c. This is a solution of exact differential equation. If it is possible for you, you can directly solve these two equations integrations simultaneously. Otherwise, my suggestion is solve these two integrations separately, take the sum and is equal to c will be the solution. Okay, so let us discuss the given example. Okay, so let me remove this part. So as I told you earlier, multiple of dx is our m and multiple of dy is our n. Okay, so let me write here properly. We have what will I do? I will rewrite the given differential equation again. Tan y plus x dx plus x sec square y minus 3y dy is equal to 0. This is given differential equation. Multiple of dx is our m. Here m is tan y plus x, and multiple of dy is our n. This bracket is our n. So x sec square y minus 3y. This is our n. So now I will check this condition. Partial derivative of m with respect to x, partial derivative of m with respect to y is same as partial derivative of n with respect to x or not. So for that, we need to know some basic formulas of derivatives. Let us find derivative of m with respect to y. Now, derivative of m with respect to y. I am taking the derivative. Okay, I am putting here. This is our m tan y plus x. You can easily see two terms are there, first term, second term, which are separated by this addition. So there is one rule of derivatives. If you have addition or subtraction, we take the separate derivatives. I will do the same. Derivative of tan y plus derivative of x. I took the separate derivatives. In case of partial derivative, if you take the derivative with respect to y, we consider x is a constant. If any function of x is constant, when you differentiate with respect to y. Derivative of tan y, you know the formula? If you don't know, I will mention here. So derivative of tan x, which is sec square x. Okay, so derivative of tan y will be sec square y. Derivative of x with respect to y. Differentiating with respect to y, so that's why x is a constant. Derivative of constant 0. 0 plus sec square y, so it is sec square y. Okay, that said, the first derivative is over. Let us move further. So let me make them separate by this line, so we will have some more space to write. Let me remove this part. Okay, this part is over. Now we have to check these two partial derivatives are same or not. Now derivative of n with respect to x. What is my n? My n is this one, x sec square y minus 2y, 3y. I'm putting it there. Derivative with respect to x, x sec square y minus 3y. So minus sign is there. Two terms are there. Getting these two terms which are separated by minus sign. When you have minus sign, we can take separate derivatives. Tell me what will happen if I take separate derivatives. Derivative of x sec square y minus derivative of 3y. Okay. See, we are differentiating with respect to what? X. This is partial derivative. This is not usual derivative. So when you differentiate with respect to x, y and functions of y are constants. So the sec square y is constant. You can take it outside. I am taking this sec square y outside. So outside, it will come outside this derivative. So in bracket, there will be x only. Minus, let us move further. Now we have to take derivative of this bracket with respect to x. But is there any x? No, there is no any function of x. So when you differentiate with respect to x, that y is constant. 3 is also constant. 3y both. This entire term is constant. And derivative of constant is 0. So this is sec square y into derivative of x 1. So 1 into sec square y, sec square y. So dabba m by dabba y, this thing, and dabba n by dabba x same. So that means dabba m by dabba y is same as dabba n by dabba x. Both of them are same. So that's why we can declare this is exact differential equation. Here dabba m by dabba y is equal to dabba n by dabba x. So that's why you can say given differential equation is exact. So yes. So when you have any problem, no, first of all you have to check whether it is exact or not. This is the first thing. If it is exact, we have this ready-made solution. Okay, ready-made solution. So simply we have to solve these two integrals and we need to add them and is equal to c. That will be the answer. But it's difficult to solve two integrations simultaneously. So that's why I will focus on this first integration only. I will find its value first, then I will find the value of second integration. I will add them is equal to c. That will be the answer. So I'm going to remove this part, so we will have some more space to write. Just a minute, huh? Yes, now integration m treating y constant. Okay, this thing you should mention each time, huh? When you solve any example of exact differential equation, you should mention that we are treating y constant. It's very important thing when you integrate. M, what is my m? This is my m. Let us put it here. M is tan y plus x. See, in second step I will not write. Okay, so yeah, I am putting the value of m. I am keeping in mind that y is a constant here. Y and any function of y is constant. As I told you earlier, when you have integration or when we have derivative, if there is addition or subtraction, we take separate derivative as well as separate integration. So I will do the same. Integration of tan y, dx will be always there, huh? Dx will be always there. X dx. So along with integration, obviously dx is there. So integration of this tan y, dx will be there. Integration of this x, dx is there. Plus sign was there between them, so I wrote the plus sign here. So y is constant, so this tan y is also constant. So when you integrate, if there is any constant, we take it outside. So tan y will come outside. Inside integration, we have just dx only, x. So you know the integration of x. So I'm writing here the formula is, okay, dx is obviously there, I'm not writing here dx. The formula is integration of x raised to n is x raised to n plus 1 upon n plus 1. That means when you have this form, x is raised to nothing is there, that means x raised to 1. So I'm going to use that formula. Whatever the power of x, we increase it by 1. If you have x square, we will increase the power by 1. So x cube by 3. If you have x raised to 4, its integration will be x raised to 5 by 5. We will increase the power by 1. So here also the power is 1 basically. So its integration will be x 1 plus 1 2 by 2. So this is tan y, integration of dx is x plus x square by 2. So this is value of first integration. Okay, so now we will focus on the second integration. So see, there is no more space to write. Make a screenshot of it first, then I will move further. So let us find the value of second integration now. Okay, now tell me what we write here. We write integration terms in n free from x with respect to y. Okay, terms in n. Where is my n? My n is here. You can see, or here is also I have written the same n. What is my n? Okay, I will write it here, so it will be easily visible for you. 3y. So this is my n. How many terms are there? First term and second term. We want terms in n free from x. There should not be any x. In first term there is x, so I will not take this term. In this term there is no any x, so I will carry this term, okay, here. But it has a minus sign, so I should write here minus 3y and integration with respect to y. In case of integration, if there is any constant, we take it outside. The constant is minus 3, you can take outside. So inside the integration, we have simply y dy. Let us move further. So this is minus 3. The same formula I will apply here. What is integration of x raised to n? X raised to n plus 1 by n plus 1. Whatever the power of x, we increase it by 1, and the same term we write in denominator. So y power is not there, that means its power is 1. So by applying the formula, we will have y raised to 1 plus 1 2 and the same number in denominator 2. So the solution is in solution what we do, we add these two integrations. So we have already found out the values of integration, so I will write the solution is value of first integration x tan y. Simply I am writing x first here, multiplication is there, plus x square by 2 plus, now we will write the value of second integration. So this is second integration, it's minus 3y square by 2. So plus minus minus 3y square by 2 is equal to c. So this is the solution. Solution is what? Sum of values of these two integrations. Okay, I'm adding these two values of two integration is equal to c. So this is a solution, required solution of given differential equation. So this is the required answer. You can note down, okay, the solution here. Now I'm giving one problem for a practice. Okay, so you can try to solve that problem, and if you have any difficulty, definitely you can watch my next video in which I will cover the solution of this homework problem. Okay, just make a screenshot of it first. So this is practice problem for you, getting? So you can try to solve this problem on your own. If you understood the procedure in this example, you can definitely solve this problem. With this, if you have the basic knowledge of derivative formulas of derivative and integration, definitely you can solve. And if you have any difficulty in that case, you can definitely watch my next video. Okay, so we'll stop here. Thank you. We will meet in next video.